Hi guys, this is Gopalakrishnan. This is my submission for the peer review project of creating a prediction model to predict the energy output for the given CCP data. So I'm going with the coding approach here. So I'm using Jupyter Notebook with a Python language for the data analysis, building and evaluating the prediction model. As a first step, I have loaded the necessary Python libraries for the data engineering and building models. Have loaded the data set using Pandas red function with dataset.info. I got the necessary details from the dataset. I think we can clearly see there is 9,568 entries and we have five columns. So that is ATV, AP, RH, and P. So with the dataset describe function, so we can clearly see what kind of a data we are having. By simply viewing that, we can see there is a data is kind of a continuous and we can see some correlation between the data. So to ensure that, we are going to do correlation mapping. That's one kind of a way to identify if the data contains has any correlations at all. So I'm using the plot libraries. I'm taking the 10 by 10 matrix and just plotted the data here. And as a result, we can see the correlation between the AT and B is almost negative 0.95. So I think the linear regression is the best at a simple model to get started with the prediction. So I have started with the linear regression here. So to start with the process, the first step will be usually the splitting the data set into the training set and the test set. So I just created kind of a split of the data set for 80 percentage for the training and 20 percentage will be given for the test data set. So let's start with the linear regression model. We are importing the linear regression model from the scikit-learn. It's one of the another Python library usually we will use for importing any models here. So to fit x and y, we are the model we are providing the x1 and y1 training values. That is x1 as will be the model 80 and y1 will be the b here. So initiate the linear regression and now we are going to predict the outcomes from the linear regression. So as you can see, the outcome of the predicting and test value is we got the data here, and it's almost nearly accurate to the 90% as the you can see the difference here, 434, 431. This particular column has a nearly more than a 90% accuracy here. To confirm that, let's do the model evaluation. It's kind of one of the main thing usually we'll do whenever we build a model. So for that, I'm going to take the auto score. The auto score as we call as a regression core score. Core function using that we are going to predict the LR score. LR score is nothing but the linear regression score. Once we evaluate that, we got just regression score. As you can see, it's kind of returning nearly zero point 0.9 votes, almost the 90% what I just told based on the data, as we see. And once we got this results, it's better to interpret with the test data. So to make sure, so the whatever the data we have, whatever the accuracy that is produced by model is correct. So I'm using the matplotlibs plot library to the scatter the values here. I'm taking the x1 test value and the y1 test value here. Also, I'm just labeling this as AT and B because we find the highest correlation between these two variables. As you can see that the most of the variables are the nearby line, the sense of the accuracy is nearby correct, but some of the variables has a little bit scattered here, so that can be omittable as we have only 0.90 as accuracy. So as we can clearly say that this particular linear regression model is producing nearly 90% data, that's okay for this kind of approach. So and for the next set of model, I was thinking about some other multi-regression model or something, but I just want to go with a little bit different approach. So say consider I thought of different models and I just came with a random forest regression. The only thing kind of make me to choose the random forest regression is kind of it uses the ensembling learning method for the regression, since it will use more than one model. predict the outcomes here in the random forestry. As you know, most of you know that, and it runs the trees will run in a parallel, in the sense there will be no interaction between the trees. That will usually products the individual errors. So whatever error happens in the tree will be there, so it must not impact with other trees. So that's kind of a thing. It's really made me to choose this particular model. So as like what we did say for linear regression, we usually load the values. Say I here the prepare the data set here. So I just kept the 80% for the training and the 20% for the test data. And I initiated the model training using the random forest regression. And once again, it is taken from the kind of imported from the sklearn scikit-learn library. So I kept the estimated value has to be 10. So I don't want to the model get runs for too much time. So I kept the estimated values at 10. I think we can provide any number of values. So post it's trained, I try to get the prediction outcomes. For that, I'm using usual values to get the predict here. So once it's outcome, as you can see that the values is 434 and 430 is more than 90 percentage. Even the consider this 454 and 460, the values are very much near here. So I assume that the values here will be more than 90 percentage comparatively what we got in the linear regression model. So and see, let's do the model evaluation, because to understand what are the values we got here to do. Let's do the model evaluation to understand if it is really provide that same data, same kind of accuracy with our test model also. So we pass the test variable, that is y to test and test data set and y to prediction here. So I'm we trying to print the RFS score, that is nothing but random forest regression score. As you can see that it amazingly provided 0.96, which is almost increment of zero point zero 0.06 percentage comparing with the linear regression model. So I can clearly say that the random forest regression model is a better model for this kind of problems. So even though we can, the random forest regression model also always produces better accuracy than the simple linear regression model. Still, we can use some famous models like ANN decision trees or the support vector recognition. But this ANN or kind of advanced neural networks is a little bit kind of a complicated method. The decision trees also we can use this method for the linear problems like this. But moreover can be used for the classification related problems, and support vector regression also in a kind of famous model. So considering the computational cost and the scope of this problem, I think the simple models like this linear regression and random forest regression is the best thing. So that's it. Thanks for reviewing my video, and let me know if any other comments, please. Thank you.